Okay, we left off talking about our account balance design. In this, we know that we're going to be doing one thing definitely. In fact, we know that this one thing is the one and only thing that's actually going to affect the status bits and E-flags. Based on this one thing, we're going to execute one of three different designs. So, easiest way to kind of wrap our head around this, because remember we knew, well, best way to do this is let's flowchart it. Let's write all the things that we might possibly do, all the processes, then figure out under what circumstances do I not want to do them. So first thing we know we're going to do is we're going to add value to balance. Okay, I know I'm going to do that. There's a possibility that I may execute the design for a negative balance. There's a possibility I may execute the design for a positive or a zero balance. And there's also the possibility that I may execute the design for positive balance. Now, I am not going to execute all three of these. So what I need to do is go back and make a decision. So I'm right here. I've added value to balance, and I want to figure out under what condition do I not want to execute the negative balance? Well, when I add value to the balance, if the balance is greater than or equals 0, I don't want to do that. So what I'm going to do is draw a decision box and say, is balance greater than or equals 0? Okay, if this is true, I want to go somewhere else. Only if this fails do I want to execute the negative balance. If I execute the negative balance, then I really don't want to execute anything else. So let's go out here. Okay? Alright, so what if this is true? What if balance is greater than or equal to 0? So it's either positive or it's 0. So let's take that down here where we make another decision. And let's say, is my balance greater than 0? And here I'm going to say it that way because the next thing below this is the design for 0 balance. Okay? So if the 0, if it's greater than 0, if that's true, I want to go down to the positive balance. But if it's false, means I know it's greater than or equal 0. But it's not greater than, therefore it must be 0. Okay? Alright, but what if this is greater than 0? Then the next thing I'm going to do is go down to my positive balance. Now, what do I do if I execute the 0 balance? Well, after I'm done with that, I want to go to whatever I'm going to do after any one of these choices. So let's say we've got a place down here called done. After the positive balance will go there, but after either of these two, we're also going to go there. Okay? So in this, you see, and this is what the critical part of this is. Look at the conditions under which we are jumping. When I write out the processes, top to bottom, and then write these conditions as though under what conditions do I not want to execute this next thing, this is going to give you a very good idea of how to minimize jump instructions. So, write down all the processes you might do, and then jump around those you don't want to do under the conditions in which you don't want to do them. Alright, we're going to have some more practice with this, but I think this is good. So, another thing to look at though is, let's go to this next slide, which is where we ended last time. You know what, actually, let's back up. You'll notice that those conditions that we just highlighted are actually the opposite conditions than what we would use in a high-level language. In a high-level language, these are the conditions under which I want to execute the next step. In assembly language, it's the condition under which I want to skip the next thing or jump around it. So that's kind of the basic difference there. All right, so we've got our basic design. Let's look at some examples. Now that we have just the simple jump instructions, I'm going to be adding some values. Always fun. So EAX contains something, EBX contains something. We're going to add the two together. Let's just go ahead and do that. I've got 0, 0, 0, 0, 0B, 2, 1, added to FF, 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 0, 0. We add it and we get 1, 2, 15 plus 11 is 26. 16 goes into that once with A left over. And it looks like I'm going to have just a whole bunch of carries. This was a 32-bit add, so my answer is this. Now, let's look at carry flag, zero flag, sign flag, overflow flag. Based on this 32-bit add, there was a carryout. The answer was not 0. I added a positive and negative, therefore there's no signed overflow that's going to occur. No, that's for this one, sorry. Sign flag is positive, so I'm okay with that one. It is 0. Okay? All right. J and S is the jump instruction. How do I know if I'm going to jump or not? Well, jump if not sign. If the sign flag, if no sign. So, under what condition does that jump? Well, in this case, you can also think about this and say, jump if sign bit is not set. So here I look at my sign bit. Oh, sure enough, it's not set. So guess what? We will jump. So will we jump? Yes. Okay. Let's do one more of these. Okay, same problem. Jump if not carry. So we had the carry flag was set. So in this case, if the carry flag is set and I'm jumping if the carry flag is not set, then this one will not jump. Okay? All right. More examples. We'll do that one in class. We'll look at this code in class. Let's look at relational expressions. So we've looked at just the effects of some arithmetic or logical expression on a single status bit in E-flags, but sometimes we also wanted to evaluate the relationship between certain values. Okay, so we've got what if we want to do that? How do we do that? So we look at a particular example. Okay, how do we know how the machine evaluates this? Well, we know how it's going to evaluate it because we know what it does. In this case, it's actually going to evaluate this is x minus y less than 0. Okay? So when I do a relational expression like that, I'm actually going to do subtraction to see whether or not x is indeed less than y. Alright, so let's show you a compare instruction. Compare, because what we do is subtraction, compare is going to do the same thing as subtraction. The only difference is it is not going to change the value of either operand. Okay, so it will do the subtraction, set the status bits and E-flags, but will not change either of the operands. So let's look at a quick example here. same values. Oh no, different values. So we'll go ahead and play with this one. So I've got 0, 0, 0, 0, 0, B, 2, 1, 0, 0, 0, 0, B, 0, 2, 1. It is a 32-bit add, or compare. Whoa. So I'm going to do subtraction. Okay, now I'm subtracting EBX from EAX. So 1 minus 1 is 0, 2 minus 2 is 0, B minus 0 is B. 0 minus B I can't do, I've got to borrow. But I have nothing to borrow from here. So I'm going to have to go to our secret friend out here, borrow a power of 16. They loan it here, I borrow here, I borrow, here I borrow, here I borrow, loaning it here. So I've got 1, 0, or 16, minus 11 is 5. 5 minus 0 is, or F minus 0 is F, 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 F. So let's look at what happened. So I've got carry flag, 0 flag, sign flag, overflow. Carry out. I borrowed from beyond our fixed length, so a carry is generated in the corresponding addition problem. It is not 0, it is negative. And signed overflow. I have taken a positive minus a positive. Well, minus a positive is the same as plus a negative. So positive plus a negative, I'm not going to have signed overflow. Okay? So that's the result when we execute this instruction. Okay? So based on this comparison, we would normally put a jump instruction after it, so that the jump instruction could evaluate any one or some combination of the status bits and E flags. Okay? Well, I said any one, but it could also be a combination, but the simple branch instructions are not enough to help us with that. So I need to be able to evaluate conditional jumps, other conditional jumps. So here we look at the relations. So jump if greater, let me show you these. Jump if greater, which is the same as jump if not less than or equal. Jump if greater than or equal, which is the same as jump if not less than, jump if less than, jump if less than or equal. Notice that there are two that are missing. And that is jump if equal, whoa, jump if equal, jump if not equal. Why are those missing? Well, those are only going to be looking at a single status bit, so those have already been covered in the simple conditional jump. So there really is no reason for us to worry about those. Okay, so I've got these signed comparison jumps. This works well when I'm comparing signed values. Okay, so in class we're going to look at a piece of code. Okay, we're going to play with a lot of code in Chapter 5. Starting in Chapter 5, we've already gotten the basic instructions down, so now it's time for us to widen our breadth as far as what we're able to do with these instructions. Okay, so we'll play with this in class. Now let's do a quick look at structured programming. Okay, so we've looked at branching and looping. We want to take a closer look at how we've translated between our high-level logic and assembly. So we're kind of going back. We looked at this a little bit, but let me just verify everything for you. Okay, in an if statement in C++, remember I'm looking at this expression. If this expression is true, then I will execute this. However, in a low-level language, what I'm going to be looking at, what I'm going to be looking at in the low-level language is under what condition will I not do that. So I'm going to increment counter, get next value. Okay, so Under what condition do I not want to increment the counter? Well, if it's negative, I do, which means if it's greater than or equal to 0, so here I'll have a decision diamond. I'll say, is value greater than or equal 0? Okay? If that's true, I'm going around this. Otherwise, I'm going to do this, and as a result, I may just fall down into that as well. Okay, but do you notice here, again, in a high-level language, this is the condition for execution of this block. In assembly language, for simple expressions like this, it is the opposite that we're going to look at to tell us when we want to jump around that. Okay? All right. Same thing here. If value is negative, I want to increment a negative counter. So increment negative, increment positive, and here I'm going to do a check. Here I say if it's negative, then do this, else do that. So here I'm going to say, under what condition do I not want to do this? Well, I don't want to do that if value is greater than or equal 0. So if value is greater than or equal to 0, then I want to go down here. Otherwise, I'm going to fall into incrementing my negative counter, and then I want to go around that to whatever get next is. Get next. Okay? All right. Awesome. Let's do a loop, and then we'll call it a video. All right. In a while loop, several things are going on. A while loop is an example of, I'm going to check the condition, okay, and if the condition is true, then I'm actually going to execute the loop. In our case, though, all right, what we want to do, let's look at under what condition, what is the opposite of my loop condition? There's my loop condition. So my termination condition is the opposite of that. So count greater than or equal limit. Okay? So that's what we're going to look at. If the count is greater than or equal limit, count greater than or equal limit, if that is true, then I'm going to go around. And I'm going to go around the loop. So in the loop, I'm going to increment the counter, and then I'm going to jump back to the top. Well, and I'm not actually even going to put that in there. Okay, so I'm going to increment this counter. After I increment the counter, then I go back up here and say, okay, is count greater than or equal limit? And it's only when that is true that I'm going to jump around this. Okay? So if this fails, that's true. If this fails, then I'm going to increment the counter and check it again. If it's true, I'm done. If it fails, I increment the counter and do it again, and so on. That's it for this one. We'll pick this up in the next video.